we have vector operations we'd like to talk about. A, B, C, D, and K represent all real numbers. Now, the nice thing about component form, vector addition and subtraction are really quick and easy. If I have vector vector in component form AB plus a vector in component form CD, you literally just add the horizontal components together and the vertical components together, and there's your new resultant vector. No more drawing of pictures. If you have a scalar factor being multiplied to a vector in component form, you literally distribute the k to both components and multiply to it. So with that scalar factor k comes our opposite vector, negative u. That's just saying negative 1 gets distributed like the k did. So now if vector u is a sub 1, a sub 2, then the negative vector u, its opposite, is negative a sub 1 comma negative a sub 2. If we're subtracting, there's two ways to approach it. You could just go a minus c, there's the horizontal component, b minus d, there's the vertical, but make sure order matters. Now, if you're afraid of making a mistake here, then simplify. Take the negative, distribute it into this vector, and then add. So a plus a negative c, b plus a negative d, you still get the same a minus c, b minus d. All right. Now, performing these operations, I'm going to show you the algebraic version, and then we'll justify all this geometrically in an illustration, but we don't have to do that. I just want to show you that graphically that it works. So a plus v, very simple. Write the components down. Negative 2 plus 4. 1 plus 3. Positive 2 comma 4 in component form. That's my resultant vector. I should go do the next problem. But if we look at graphing it, u vector will be blue, v vector will be red. Draw out my xy coordinate plane. All right, vector u, negative 2, positive 1, there it is. 4, 3, 1, 2, 3, 4, 1, 2, 3. There you go. Now, nose to tail, take the red vector, take the initial point, put it at the tip of the blue. And there's my component vector, and notice it's at 1, 2, 1, 2, 3, 4. There's the component form. Or, if you wanted to, you could also do it this way. Graph your negative 2, 1 from this point, treat that like the origin, and go 4, 3. 1, 2, 3, 4, up 1, 2, 3. There, you're at the terminal point. There's your resultant vector. So two nice ways to look at it graphically. Negative 2u, okay, take negative 2, multiply that to each component. Negative 2 times negative 2 is 4. Negative 2 times 1 is negative 2. Done. Graphically, negative 2, 1, there's the blue vector. Now, the component vector multiplied by negative 2. Here's where the slope can come in. This is at negative 2, 1. Now I'm going to do everything opposite. Down 1, right 2. Now do that twice. Down 1, right 2, down 1, right 2, and there's negative 2u. 3u minus 2v. All right, time to distribute. 3 multiplied into here, so I see negative 6 and a positive 3. You can distribute the negative 2 into v. So I see negative 8 and a negative 6. Once I multiply that out, there they are. Now add the two horizontal components, or what I would say the two x components, negative 14 and 3 plus a negative 6, we'll call that a negative 3. So negative 14, negative 3 is my resultant vector. So if I want to look at that graphically, I'm going to have to move my xy axis, my origin, way over here to the right to get this to all fit. 3u. Okay, so again, look at my blue u here. 2 to the left, up 1. I got to do that 3 times. 2 to the left, up 1, 2 to the left, up 1, 2 to the left, up 1. There is 3u. All right, my negative 2v, which was negative 8, negative 6. So from this point, we're going to go negative 8 to the left, down negative 6. just off the graph, slide that tip to there, and we have it. Or, from this point here, the tip of 3u, from there count 1, 2, 3, 4, 5, 6, 7, 8, down 6, 1, 2, 3, 4, 5, 6, and there's the tip of my resultant vector. All right, the next notation we're going to look at is unit vectors. A unit vector is a vector with a magnitude of 1. The two very important unit vectors that we're going to define are I and j. I is a unit vector along the positive x-axis. Component form 1, 0. J is along the positive y-axis. 0, 1. I do not like scripted letter vectors. Whenever I get a chance, I like to use the bold-faced I and the bold-faced J with no italicized. I see that, my brain thinks imaginary numbers. Oh, that's the square root of -1. Well, we don't have that in vector form. So IJ form, or standard form of the vectors, is just taking component form 3 and multiplying it to the unit vector I, and 4 multiplying it to the unit vector j, and we write this as a binomial. Now, I know we're introducing these variables. Why would we make something more difficult? It's because when you get to calculus, you're going to be looking at three-dimensional vectors, and there's going to be some operations where you have to, you have to use matrices. And if you remember using like 3x3 matrices for determinants, or the Gauss-Jordan elimination method, don't worry, we'll review that here in this class in just a couple weeks. But you need variables. You would have another unit vector, k vector, where it basically comes out at you to make a 3-dimension. So we need those variable unit vectors to set up our matrices. So that's why we have the two forms. So 3, 4, there's the endpoint, there's 3i, there's 4j. The graphic approach nose to tail of your two unit vectors. So if we did some operations with these, vector u is equal to 2i. Notice there's no j, so that means it's a plus 0j. It's optional to put that in there, but it's not necessary. And v is 1i minus 3j. So if I wanted to find 2v, take the 2 and distribute it into the v vector, 2i minus 6j. 2u plus 3v, okay, here's that u vector. Optional to put 0j, it's not needed. Just putting it there if you want to see it. I probably won't do it in the future. 2 times 2i is 4i. That becomes a 0j, so it's basically eliminated, simplified itself out. Then we got a plus 3i and a minus 9j. Combine the 4i and the 3i to get 7i. There's my standard form and ij form, 7i minus 9j, or again, component form 7 comma negative 9. V minus 3u, again, 0 is optional, not needed. Distribute the negative 3 to get a minus 6i, no change to vector v. Combine your i's, 1i minus 6i, negative 5i, minus 3j.